A mosquito factory in Brazil is on the brink of releasing 5 billion genetically engineered mosquitoes across the country for the first time ever. This might sound like the plot of a sci-fi movie, but it's actually an ingenious scientific breakthrough. We all despise mosquitoes not just for their irritating buzz and itchy bites, but because they are the deadliest animals to humans, responsible for more deaths than any other creature due to the diseases they spread. Before diving into the science behind this ambitious project, it's worth asking, could we just eradicate all mosquitoes? Nature Journal analyzed this question and found that the extinction of mosquitoes wouldn't have a catastrophic impact on humans. While some species do rely on mosquitoes, such as certain birds and fish, they would likely adapt by preying on other insects. Additionally, while mosquitoes do play a role in pollination, they are not essential to human survival. There are approximately 3,200 mosquito species, but only about 200 of them bite humans. Despite the potential benefit to humans, outright exterminating mosquitoes is not feasible and could have unpredictable ecological consequences. This is where the factory's approach comes in. Scientists have developed a method to combat disease transmission without eliminating mosquitoes entirely. They use a bacterium called Wolbachia, which has been studied in mosquito biology for over a century, but has recently gained attention for its potential benefits. Research has shown that when mosquitoes carrying Wolbachia are infected with viruses like yellow fever or dengue, the bacteria interfere with the virus's ability to replicate. As a result, the viruses cannot spread to humans effectively. By releasing mosquitoes that carry Wolbachia into the wild, these modified mosquitoes can mate with wild mosquitoes, spreading Wolbachia through the population. When an infected male mates with a non-infected female, the eggs they produce are also infected with Wolbachia. Over time, this method reduces the overall incidence of diseases transmitted by mosquitoes without needing to eradicate them entirely. When a female mosquito carrying Wolbachia mates with a male that doesn't, her eggs will still hatch, but all the resulting offspring will carry Wolbachia. Similarly, if both parents are infected, their eggs will hatch and the entire brood will carry the bacteria. This process ensures that over several generations, the proportion of mosquitoes with Wolbachia rapidly increases. Deployment of these modified mosquitoes has been conducted in 14 countries, typically lasting between a few months and 6 months. During this time, the released mosquitoes breed with wild ones, spreading Wolbachia throughout the population. Importantly, this has led to a significant drop in disease cases. For example, in Indonesia, one of the first comprehensive studies showed a 77.1% reduction in dengue cases, meaning individuals in those areas were about 4 times less likely to contract the disease. Although some sites reported lower reductions, as low as 38, this variation may be due to the time it takes for Wolbachia to fully spread in different community settings. A recent study in the Abora Valley, Colombia, published in November 2023, showed an impressive 95-97 decline in dengue fever cases, bringing the rates to their lowest in 20 years for that region. This is particularly notable because the rest of the Americas experienced a severe dengue fever outbreak, the worst since 1980. Despite the rise in dengue in other parts of Colombia, the region with the modified mosquitoes saw a dramatic reduction in cases. The project in Colombia began in 2015, and seeing such a significant reduction after almost a decade is remarkable. Currently, efforts are underway to expand this approach. In Brazil, where dengue and Zika are major issues, a new facility is being developed with the capacity to produce up to 100 million mosquitoes per week, aiming to extend the benefits of Wolbachia to even larger areas. In Brazil, we're preparing to deploy these mosquitoes across multiple cities to combat dengue fever. You might be concerned about whether humans could be infected with Wolbachia from these mosquitoes or if there's a larger risk associated with its widespread presence. However, it's worth noting that about 50% of all insects naturally carry Wolbachia, including the common house mosquito that everyone has encountered. If Wolbachia were harmful to humans, we would already be aware of it. Currently, there's no evidence linking Wolbachia to any negative health outcomes in humans. The World Health Organization is evaluating this technology for use in other countries. The scientists behind this approach view it as a complementary measure rather than a replacement for existing dengue vaccines, especially in high-risk areas. In the long term, this innovative method could significantly reduce the number of people infected with dengue, potentially saving hundreds of millions from illness. This groundbreaking approach highlights how innovation and unconventional methods can profoundly improve lives on a large scale. A special thanks to Dr. O'Neill for explaining this fascinating science. If you enjoyed this video, please give it a thumbs up and subscribe for more updates.